Hi guys, so in this video we are talking about transverse pulses. Now you must be wondering, what does transverse mean? Now to illustrate it, I'm going to generate a pulse in this string of beads. Now the string of beads over here, that we call the medium, because that's the substance that is going to carry forward the energy of the wave. The wave's energy will move through this medium. Okay, now if I generate a pulse is just a single disturbance. So a wave would be multiple disturbances, whilst a pulse is just a single disturbance. So if I just generate a single disturbance, and this is going to be in normal speed, there goes my pulse. So you would see that the bar over there on the left hand side only moved up and down once. So that was a single disturbance. Okay, now there's a few important properties when we study transverse pulses. Now, the first important thing of a transverse pulse is the fact that it is transverse. Okay, why is that important? Here, the bar moved the first bead up and down. What happened with the wave? The wave traveled perpendicular to that at a 90-degree angle. The energy traveled perpendicular to the disturbance that was created in the medium. So if I do this in slow motion, you will see there it goes up and down. It generates a pulse, and the pulse moves perpendicular to the disturbance that was created over there. So that's the first important concept that you have to grasp of transverse pulses. Another important concept of transverse pulses is what we call the amplitude. Now, what is the amplitude? Now, the amplitude, I'm just going to generate this pulse and then pause the video. The amplitude is the maximum disturbance from the rest position. So the rest position is represented by that dotted line. It's not really there. It's an imaginary line that we put there where the beads will be if there's no disturbance through them. Okay, so that's the rest position, that dotted line. And the amplitude is the maximum distance from that rest position that the beads will reach. Now, if I increase the amplitude over here, and I'm just going to let this pulse finish first before generating another one. So there it goes. So now I've increased the amplitude. Now you will see the displacement from the rest position is much greater. Okay, if I decrease the amplitude, let's just let that one run. I've decreased the amplitude now. Now you will see the displacement from the rest position is smaller. Okay, so a smaller rest position amplitude then means that the pulse is a bit smaller. Okay, it's not as big. Okay, now there's another concept that is important. This we call the pulse length. Okay, now that's how long the pulse is. Now on this simulation, they talk about pulse width, and there's seconds over there. We don't do it that way. Okay, so pulse length is like any other length we work with in physical sciences. It is in meters. So let's assume that represents 0.5 meters. Okay, so, and then I'm going to increase the amplitude just a bit more because that amplitude is really, really small. So it's not really visible. So let's just let that one finish. Okay, so let's generate another pulse. Okay, now where's my pulse length? The amplitude there from the rest positions to the maximum displacement from the rest position. Okay, my pulse length is from that bead over there, which is on the rest position, to that bead over there, which is on the rest position again. It's the width of my pulse, how long the pulse is, okay, in the horizontal, not in the vertical. The vertical is the amplitude. In the horizontal, we get the pulse length. Okay, so if I decrease the pulse width, let's just let that one go. Okay, so in slow motion again, I've decreased the pulse width. Okay, so now you will see my pulse length is not as long. It's a bit shorter. Okay, so we've got three important concepts that we have to remember. Okay, so the one is the rest position, which is the dotted line over there, which represents the position where the medium will be if there's, or the particles in the medium will be if there's no disturbance. Okay, then we have the amplitude being the maximum displacement from the rest position. And then we have the pulse length, okay, the pulse length, which indicates the distance of a single pulse. Okay, the most important thing after those three concepts that you have to remember, and this is really fundamental to the understanding here, is how the disturbance is generated in a transverse pulse. The disturbance, like we said before, is up and down, whilst the displacement or the propagation of the pulse is perpendicular to that. So I hope you guys enjoyed this video, and you're more than welcome to play around with this simulation yourselves as well. Cheers.